Hi everyone, I just wanted to go over question number 5 from the Red Personal Math Trainer today, or actually it would be yesterday now. I had several questions about this one. So first of all, the graphing part of it, the lines that you have to draw, you would have to start at point A and then continuously drag that to point B. So you would use the line segment AB to go from A to B. Point A is at -5,4 and point B is at 0,4. So you click AB and then you start by going to -5,4, which would be here, and you click, but then continue to hold down your mouse. You're going to go straight across to 0,4 because that's where B is. So this is point A, -5,4. This is point B, 0,4. Now to get to the next line segment, you're going to click BC, and from the point B that you've already drawn, you're going to go down to 2,1. So again, you're going to click from B, but hold down your mouse, and then 2,1 would be right about here. And that's line segment BC. You're going to continue the process, so you click the next segment, you start at the point that you left off at, and then you're going to hold down your mouse and continue to the next point D, which is 5,1. So 5,1 would be 1, 2, 3 right here. And again, I'm going to continue the process. DE, it goes from 5,1 to 5,-2. So 5,-2, I'm holding down my mouse, is here. And then EF goes from 5,-2 to -5,-2. So that holding down my mouse, I'm going straight across to -5,-2. And then last FA would just be connecting these 2 points. Again, you click, hold down your mouse, and then unclick when you're done. So that's how you actually draw the image. What you're going to do next is figure out, since this is a composite shape, what shapes you can actually divide it into to find the area. So what I'd like to show you is just a quick review of actual composite area. So just fast, hopefully you recognize these formulas from previous years. The area of a parallelogram is equal to the base times the height. The area of a triangle is 1/2 base times height because a triangle is actually half of a parallelogram. The area of a rectangle we've spoken about is length times width, and the area of a square would be side squared. Just make a note that the base and height of a parallelogram and a triangle are perpendicular. And if you remember perpendicular, they mean that they are two intersecting lines that form a 90-degree angle. The symbol for perpendicular is kind of an upside down capital T. And if you look here, this height, let me highlight it for you. The height of this parallelogram is perpendicular to the base. Same thing with the triangle, the height is perpendicular to the base. Another shape that we need to know the area of is the trapezoid. A trapezoid area is equal to 1/2 height times the quantity base 1 plus base 2. Base 1 and base 2 are parallel to each other, which means they never actually touch, and that's what these little arrows indicate. It means that this base never will touch this base. And then the height is perpendicular to both bases. So the height is a straight line from base 1 down to base 2. What you need to remember is PEMDAS, the order of operations. You're going to do parentheses first, so you add the two bases together, and then you have to multiply by the height and then multiply by 1/2, or alternatively divide by 2. So an irregular or a composite figure is a figure made up of simple geometric shapes, but it does not have an area formula that is easy to use. What you have to do to find the area of a composite figure is to divide it into shapes that you know how to find the area of. For example, if you look here, this is an irregular shape or a composite shape. It's actually comprised, though, of a square and a half circle or hemisphere. I'm sorry, a semicircle. To find the area of a square, again, it's side squared. If you go back to this green formula, area equals side squared. So we're going to do 12 times 12. 12 times 12 is 144. So the area of the square section is 144. And then we need to find the area of this semicircle. So the area formula for a circle is from 9-2. We did that in school last week. that is pi times radius squared. Now, it doesn't say here what the radius is, but we know that since this is a square, this length here has to be 12. And hopefully you can recognize that this length that I'm highlighting is the diameter of the circle. So if the diameter is 12, that means the radius is 6. So what we need to do is 6 times 6, which is 36, and then multiply that by pi. And if we do that, you get 56.52. And now we found the area of the semicircle as well as the area of the square, but to find the area of the entire irregular figure, you have to add those two numbers together. So 144 plus 56.52 is 200.52 meters squared. Again, for area, it's meters squared. I think I just have this, I have it written down here, the work. Remember, you are allowed to use a calculator in this module. You just have to remember your order of operations. Make sure since your calculator doesn't have a squared button, that you do 6 times 6, which would be 36, and then you're multiplying that by 3.14, and then we did that half since it's half of a circle, it's not the entire circle. So we found the area of what the whole circle would be, and then multiply that by half. That's where the 56.52 came from. One more example I want to show you is this example. I'm going to show you how to solve it in two ways. The first would be to divide it into two rectangles, and you have a couple of options. If you want, you could divide it that way, so you have this rectangle up top and then this rectangle on the bottom. Alternatively, you can also divide it into this larger rectangle and then this little square here, and that's how I'm going to go about doing it. So if we look here, the square is 2 inches by 2 inches, so that means the area of this square is actually 4 inches squared. And now we have to figure out the area of this rectangle, but in order to do that, we need to know what this length is. So what this 8 inches represents is the entire, one second guys, sorry. The entire length of this figure, but we were removing this 2-inch section because that's part of the square. So basically it's 8 inches minus 2 inches, which means that this yellow highlighted length would be 6 inches. So this rectangle is actually 4 inches by 6 inches, which would make its area equal to 24 inches squared. And then in order to find the composite area, the total area would just be 24 plus 4, which is 28 square inches. Alternatively, you can look at this rectangle or this composite figure as one giant rectangle, and I keep clicking this dotted line just to show you. It's basically this huge rectangle minus this little square area that's missing. If you look at the dotted line. So if we were looking at this red dotted lines to make a rectangle, it's 4 inches by 8 inches. So 4 inches by 8 inches would be 32 inches. And then again, this little missing part is a 2 by 2 square, which would be 4 inches. So 8 times 4 is 32. And then this missing square is 2 times 2. But instead of adding them together, you're actually going to subtract them, because we're removing that little section. And then 32 minus 4 is 28 inches squared, which again is what we got the first time we solved this problem. So I just want to show you that there's definitely more than one way to look at an area of a composite figure problem. You could divide it into whatever shapes you see. Just make sure you're using the correct formulas and that your math is correct. I hope that helps. Today, you're going to review some more area of composite figure problems, and then tomorrow we will move on to surface area. Have a good day, guys.